Hey everyone, if you haven't met me yet, my name's Brian. I'm an engineer at Lookback, but prior to that, I was the iOS tech lead at the Wikimedia Foundation, which is the nonprofit behind Wikipedia. And I'm here today to talk about visual and unit testing for internationalization in an iOS app, specifically what we were doing in the Wikipedia app. Most of you probably already know Wikipedia is available in a lot of different languages, so it may come as no surprise that the Wikimedia Foundation has a very strong multilingual culture, which is what you would expect when your mission is to make the sum of human knowledge available to everyone for free across the entire globe. So here to talk today specifically about Right-to-Left support. You've heard it mentioned at a couple of talks yesterday, actually, which I was pleasantly surprised to see. But before joining Wikipedia myself, I hadn't really given a whole lot of thought to right-to-left support. I thought of internationalization mostly in terms of translations and date and time formatting, and I had been aware of right-to-left languages, but I didn't really know what the implications would be for actually supporting those in an iOS app. Just a quick survey. Does anyone in the audience today actually speak a language that's written from right to left? All right. Yeah, we got quite a few here today. So just quick crash course. So right to left, often abbreviated as RTL, signifies the direction that the language is written in. So for an RTL language, it's written from right to left. English and French and German languages are all left to right, as you can see here. But what does that mean? Why am I here talking to you about this today? So it's really important because you can imagine how growing up reading from right to left, you kind of expect a lot of things to be from right to left, same thing for left to right. And you can imagine how users using your application are expecting things to follow certain norms and conventions, and when they don't, like this slide, it's just kind of weird. It's a little frustrating. You might leave some one-star reviews like we saw in the Microsoft presentation earlier. So yeah, it has really, really big impact on your app's user experience. So supporting right to left is really important in the countries and languages that flow that direction. Above that, though, it's also about kind of a responsibility that we have as technologists to make products that are more inclusive and not just kind of built for ourselves. This applies both to internationalization and accessibility. For more information on right-to-left support, especially on the web, I encourage you to check out my former colleague from Wikimedia's talk, Moriel's talk on RTL. There is a link later in the slides. And for her website that inspired this slide is rtl.wtf. It's good. It's good for a laugh and also just some insights to kind of put yourself in those people's shoes. So not only is it important for the lofty reasons that I mentioned earlier, it's important because Apple says it's important. With iOS 9, they made a lot of really big strides to improve right-to-left support, both at the framework and tool level, but also at the OS level. You can see some screenshots. Try not to pay too much attention to my dogs. I know it's distracting. On the home screen, the rightmost home screen is the first one. This is the opposite to how it is in left to right. So to get back to like the last home screen, I have to swipe in this direction and navigate to the left. Same thing with on the settings app, all the disclosure indicators are on the left, pointing to the left. This is the opposite to how it is in LTR, where when you tap one of these, the view pushes in from the right. In RTL, it pushes in from the left. And the last example on the notification center, you can see the primary tab is the one that's selected on the right. Everything, you can see across the board, everything in general is flipped. Even here, the list items in my to-do list are flipped, and you can kind of forgive me for procrastinating so poorly on my taxes. But as great as iOS 9 is, it doesn't do everything for you, and there are a couple of things you need to do as a developer to support right to left. In particular, I want to focus on the 5.0 update that was recently shipped for the Wikipedia app, in which we redesigned a lot of parts of the user interface in a very big way. And as a result, we had a lot of new views, so we had to do RTL support for a lot of these new views and new navigation scenarios. So what we're looking at here is the Explore tab in the Wikipedia app, and on it we have some table view cells that display little previews of the article. You can see the title, the description, a little snippet, and then a button to save it for later for offline reading. And it looks pretty straightforward, right? But I'm not here to talk about like how we made it RTL. I'm here to talk about how we tested it. And the reason why we decided to test it, or rather why I decided to test it, was because we were building a lot of new views. We were iterating really quickly, and we would get these mocks from designers in LTR. And we're trying to move quickly, so we implement it, we test it in the simulator, and we kind of push it to master. And then only later in code review, or even maybe later in QA or in our beta channel, people would submit bug reports and say, hey, this is actually broken. It doesn't look right on RTL. Or even worse, it looks okay in iOS 9 in RTL, but not in iOS 8. So what can we do to kind of add more mechanisms for tighter feedback loops around RTL support to ensure that it's not something that we just have to like try to remember as developers to do? Let me just enable caffeine here. But let's think for a second about how we would actually test these. These are views. This is not like a function that you can make sure it has the proper output for a certain input. It's not some delegate callback interaction pattern that you can test. So given that they're views, how will we test these? The views themselves look pretty straightforward, pretty simple, just an image and some text. And it would be easy, except that Apple doesn't really give us any tools to do visual tests. You might not have even really heard of visual tests before today, or maybe never written one. Luckily, Facebook has created a framework for visual testing called FB Snapshot Test Case, which is what we use at Wikipedia for visual tests, and what I'm going to be demonstrating how to use in a bit for doing visual tests. But okay, so we kind of have an idea how we're going to do the visual tests. What about RTL? That's why I'm here today. So RTL is actually governed by the state of the application. It's set at launch time based on the device language. So you might have, if you're already working on RTL support, you might have tested it yourself by running the app, or like going into settings, changing the device language, rerunning the app, making sure it looks okay in both cases. But how do we do that in like a unit test, for example? Well, Apple provides a bunch of different tools for testing localizations in general. You can do double-length pseudo-languages to simulate situations like Felix mentioned yesterday in his talk in like German, where the cancel button is like 5 lines long. But you can also do stuff for just setting the device language at launch time to override the device settings. So we can use this to toggle different languages and test our views in different scenarios at the unit test level. But that means we're using launch arguments. That means we need to launch the app multiple times. So this might sound a little bit daunting from an automation perspective, and this wouldn't be mobile delivery days if I didn't do some automation. So I'm going to show you guys how to automate the test runs with Fastlane. So just to provide a quick crash course on visual testing, how many of you are actually writing visual tests right now in your app? Got just a couple. So in a nutshell, it's basically 2 steps. You snapshot a view, and you compare it with a pre-recorded reference image. Pretty straightforward. So take a quick look at these 2 images and try to compare them in your head and think whether or not this would be a pass or a fail. Actually, it would be a failure. They look to the naked eye almost identical, but this goes to show both the power and the great responsibility that comes with visual testing. They can really strictly enforce pixel perfection, both as something that you can really nail down at design time, but also, oftentimes you run into situations where you might want to have a little bit of wiggle room due to certain situations where you need tolerance. So how about we write one? I'm going to try to speak a bit louder, see if you guys can hear me. All right. Everyone see that okay? Take that as a yes. So, if anyone's familiar with unit testing, you just create a new file, a new test class, and since we're writing a visual test, we're going to make it a subclass of FB Snapshot Test Case instead of the usual XC test. Whoops. And since we're testing the cell that I showed you on the previous slide, we're just going to have it as a property of our class, and we're going to create an instance of it in our setup method. So, as I mentioned, visual testing comes in two parts. Hoping this is coming through on the stream and the video, so I'll move a little bit closer. Okay, so just a quick recap for the stream. We've got our class, subclasses from FB Snapshot test case, and we're going to create a little test. So we saw the cell before, so let's just create a simple test that adds in some basic properties of the cell, just fills out the labels with some text, takes a snapshot. What was that, Siri? Sorry about that. So yeah, we set some text on the label, and we take a snapshot to compare it with a reference image. But we don't have one yet. So what we need to do is actually enable record mode in our visual test. This will tell the snapshot assertion to actually record the reference image. So why don't we go ahead and run this. I'm having trouble finding my mouse. There it is. So we run this just to see what the result of the test would be. And it failed. So think about that for a second. You don't want your tests to pass when you're actually recording the reference image. So that makes sense. But we got our reference image. So that's what we wanted. We enabled record mode, and that looks pretty much like what the mock says. So let's go ahead and lock that down by disabling record mode, running the test again, and see what happens. Success. The test passed. So that means that our cell, when set with this text in the label and taken a snapshot of, it looks just like or within 5% of our reference image. So that's a visual test. Didn't really take that long. But that's only the first part. As I promised, we're also going to automate it. If I can open my fast file. So as Felix mentioned yesterday with Fastlane, it's kind of like Rake, if you're familiar with the Ruby task management tool. You define a lane, you define some actions to take in that lane, and in this case, what we want to do is just run our unit tests. So this could also apply just for automating unit testing in general for any project. So we're going to create a new lane that runs our unit tests. So lane, run unit tests. I'm using the destination argument to specify a specific OS and simulator, because with visual tests, you're running on a specific screen, and if the simulator changes across visual test runs, you could get false negatives. So we want to use the same simulator every time. All I need to do is tell scan, one of the ways you can run unit tests in Fastlane, the scheme to test, and it'll run the tests for us. So I'm not going to run the entire lane for you here, but just to show you what it would look like, we call Fastlane run tests. It grabs our Xcode scheme, starts building and compiling the unit tests, and it'll eventually run them. But as we just saw before, they pass in Xcode, so I'm not going to waste your time by running through all of that automation right now. But we're looking pretty good. We got our LTR snapshot. We got a visual test that passes, and we've automated it. We're done, right? We're done. Ah, see, I forgot again. We got to do RTL. So back to Xcode. And as I mentioned, we've got our visual test, and we're using a scheme that's, kind of vanilla. And how would I just think for a second, how are we going to actually test this cell in RTL? And we've got our UI application that has a user interface layout direction that's read-only. So I can't just set this in a separate test and rerun, the assertion to check against a new snapshot. I actually need to either go into the simulator, into settings, and you can see this is obviously not going to be viable. So we need another way. And there is another way, or I wouldn't be here today. So what we're going to do is create a new scheme in Xcode. It's going to duplicate the scheme that we have already. I'm going to name it Wikipedia RTL. And you see here there's a field for arguments that you can pass on launch. And what we're going to do is add two. This is a bit small. All right. So we add two arguments. One for Apple locale, which is basically the same as overriding the current locale when you run the app, and we're going to set it to Hebrew. And one other one for Apple languages, which sets the preferred languages for region formatting and things like that. And when you set both of those together, they can also affect the user interface layout direction of the simulator when you run the app. So this is useful not just for unit testing, but also as a quick way to switch between LTR and RTL when you're just debugging in the simulator. So we've got our RTL scheme that we're going to be using for testing, and let's go ahead and run our tests. In the meantime, oh, that's much better. Okay, we are testing, and it failed. Well, we recorded the snapshot earlier and it was fine, but we're running an RTL now. So if you guys can see this, this is a Xcode plugin that Orta from CocoaPods and Artsy wrote to more easily see the results of snapshot tests. But snapshot test case will also tell you in the console where the failed image is. It'll show you a diff of the two images to show you what went wrong. And here you can see on the left is our reference image, and on the right is what we actually recorded during the test. So on the left, it looks right for LTR, but on the right, that actually looks right for RTL. Everything's on the right. The save button's on the right. So how are we going to choose the right reference image based on how we launch the app and what the writing direction is? Well, snapshot test case allows you to specify an identifier for the reference image that it should use. So what we want it to do is pick the LTR reference image for LTR and the RTL reference image for RTL. And an easy way to do that is to just specify the identifier for that based on the state of the UI application. So there's a UI application category that we wrote that gives you the user interface layout direction as a string. And if we use that, it'll pick the correct reference image for that test run. So since we don't have a RTL reference image, I'm going to go ahead and re-enable record mode so that we can obtain it and use that to verify this view in RTL. So as we saw before, it's going to fail because we're in record mode. So if I disable it now and rerun the test, success. So that means our cell looked just like our new snapshot, which you can see has the RTL suffix, and it looks like this, which is exactly what we want. So instead of rerunning in record mode the LTR test, I'm just going to add the suffix to the reference image we have already, since it shouldn't have changed. And if I just switch the scheme here back to the regular one, rerun the same test without changing any code, passed again. So now we have two schemes, one test for verifying the same view in LTR and RTL. How are we going to automate this? We go back to our fast file. We've got our one lane, which runs the tested one scheme. So we need to run the same test, but we need to do two schemes back to back. So what I suggest we do is have another lane that runs all the tests and use an ability in Fastlane to call different lanes from within another lane. So you can see here, for each scheme, Wikipedia and Wikipedia RTL, we run the tests for that scheme. So that means we need to add some kind of parameter to our other lane, which Fastlane allows you to do with an options hash map, which contains, just like a JSON, not a JSON blob, but like an object with different fields that you can use to parameterize your lanes. So in this case, we're only passing the scheme, so we can say the scheme that we're running is either the one that we get from the options argument or a default of the Wikipedia scheme. And instead of hard coding in that here, we pass it as an argument, and we're pretty much ready to go. Again, I'm not going to run the whole thing, but you can see if I run all tests, it's going to first start doing run tests with our regular scheme, and then it'll finish all of that and go through and run the RTL tests. And therefore, you now have LTR and RTL verification automated. So, how about you guys? But feeling like I got some new superpowers right now. We can test LTR, we can test RTL, we've got this cell. We can test it in all these different situations with an image, with a longer description. This also lets you verify auto layout constraints in LTR and RTL. So this is awesome. So we want to visually test all the things, right? That's like, you just want to use these powers for good. But there are cases where visual tests don't always work. As I mentioned earlier, there are cases in RTL where navigation is also flipped. And this is a case where visual testing doesn't really do you a whole lot of good. Shown here is the gallery view in the Wikipedia app. Here it's starting on the left in LTR, and I'm going to the right to see more images. Here it is in RTL. You can see the top items are flipped, the text on the bottom is flipped, and I'm going to the left to see more images. So how do we test this? You can't really use visual tests. Ideally, you'd have functional tests, but I'm going to talk about using unit tests to actually verify this functionality again across LTR and RTL. Before I get into that, talk a little bit about the different galleries we have in the app. We have a full screen gallery. We have this gallery embedded at the top of the article, which you can use to just easily swipe through all the images in the gallery. Basically, there's just two different view controllers which just display a collection of images. So we have this gallery, and they need to get a data source to figure out the images that they're going to display. And so we have this architecture that has like a single interface that the galleries use to figure out the images that they're going to display. And the reason I'm telling you all of this is because it allows us to test it in a much simpler way, to also drive home the point that it's not just QA and test engineers that need to think about tests. It's really, really important for developers to be thinking about testing at the architecture level, because it allows you to leverage these abstractions and test them in a much simpler way. So back to the problem at hand, we have these galleries, and here's the order that the images in the actual collection need to be in order to be laid out properly in iOS 8 and iOS 9 in LTR and RTL. So every gallery we have in the app needs to share this kind of behavior, whether it's a full screen modal gallery or it's a gallery at the top of the article. They need to share this behavior. And I keep repeating shared behavior because that's a concept in behavior-driven development, specifically in many BDD frameworks. It's a convenience that they provide for you to simplify these kinds of tests. And we're going to run them on iOS 8 and iOS 9. So I'm just going to quickly show you how we did that. All right. So here we have our shared behavior. It's using the library called Quick, which I link to later in the slide. And the concept with behavior-driven development is that you're going after behaviors. So you use these kinds of clauses saying an RTL-compliant data source should reorder the items if necessary. This is much more readable than the typical XC test case, test should blah, blah, blah. It gives you a much more expressive, much more understandable format to understand the behavior that you're trying to test. So if we have some kind of gallery data source and it should reverse the items if necessary, we need to set the expected items based on what the environment is. So it should reverse the items if the operating system is less than iOS 9 and the application is RTL. So if both those things are true, the items inside should be reversed, and we just write an assertion that goes through the items in the data source and the items that we expect and verifies that they're in the correct order. So that's the one test that we need to share across all of our galleries. Typically, you might want to think, intuitively, I'm just going to copy and paste this into 3 different tests, and there you go, there's my shared behavior. But what behavior-driven development, specifically these kinds of frameworks, allow you to do is specify that each of your data source implementations behave like an RTL-compliant data source. So we have our base class that behaves like an RTL-compliant data source, and in order to run that test, it just specifies the context. So that test above is run with these items in this data source. Same thing down here. For our article gallery, we create an article gallery data source and say it behaves like an RTL compliant data source for the images in this fixture for the Barack Obama article. We also have a picture of the day feature in the app, and it also behaves like an RTL compliant data source. So we have these like 3 or 4 scenarios that all share the same behavior. You specify the behavior once, and you opt into it in all the other cases that need to behave in that fashion. But as I mentioned, this has to happen on iOS 8 and iOS 9. So we can manually test that just by toggling to a different simulator here. But again, this is mobile delivery days, so let's automate it. So already we're running the schemes back to back we can also do the same thing with the OS versions. So we can say for each OS version, 8.4 and 9.2, we will run our tests with that version. So the same way we did with our schemes. So this means we need another argument, so we can say the version we're going to use is, oh wait, I forgot to pass it here. So there, we call the run test lane with the version in the scheme that we want. And so the version that we're going to use is either the one we got from the options parameter, if I can type, or we're just going to default it to iOS 9.2. And again, I have this destination argument here. All I have to do is interpolate the version, not versiono, version argument here, and it'll run the tests in the scheme that I specified on the simulator OS version that I specified. So now we have iOS 9, iOS 8, LTR, and RTL coverage. So I know what you're probably thinking. There is no way this is going to run in less than 10 minutes back to back, because each time the tests are recompiled and then all of them are rerun. So if we have a serial process that takes a long time, the first thing that comes to mind is wanting to parallelize it. So how are we going to do that? Well, the Wikipedia team is using Travis on GitHub, and Travis has a build matrix feature that you can use to run multiple builds in parallel. So what we did is we used the environment variable build matrix parameter to specify a couple of environment variables that we use to pass different arguments to Fastlane. So when we create a pull request, one build agent spins up and does the run tests Fastlane action. Another one does it with the RTL scheme. Another one runs it with LTR in iOS 8, and another with iOS 8 RTL. So what does that actually look like when you run it on GitHub? When they pass, it looks like this. You have your Travis build report, and for each agent that your pull request ran, you can see it's passing the different arguments to Fastlane, and when they all pass, your pull request passed because it's compliant with RTL in iOS 8 and iOS 9. So from here, I'm hoping that we can start to get into the area of functional testing, because ideally we'd be able to say that, yes, when I actually swipe in the gallery in LTR and RTL, it goes where I expect. I'd also like to be able to run these on a device, maybe add in some more device models to do different screen sizes, because in some cases these are visual tests. And as you might have seen on the last slide, the total runtime, it wasn't exactly all of these run to back. We saved a little bit. We didn't save as much as I would like, not only because we have to recompile every time, but also because wait times for build agents can be a bit long, depending on whether or not you're paying for Travis or Circle CI or whoever your provider is. And here are the references that I made to the internationalization docs, to Fastlane, to the frameworks that I used, and the RTL talks I mentioned. Some other reading that I recommend for supporting right-to-left languages, more information about snapshot testing, and just more information about RTL and iOS 9. And that's all I've got for today. Thanks. I'd be happy to answer any questions. In some cases you can. It really depends on the view you're testing, but oftentimes, especially in like table view cells, table views have a little bit of differentiation in how they actually ask the cell to lay out its content across iOS 8 and iOS 9. And you'll often need to like add in little like workarounds to say, okay, now that I've set the properties, I need to call layout if needed so that it renders properly and fills vertical space and expands properly when the text is longer. And visual tests are a great way to make sure that it looks proper in iOS 8 and iOS 9, because another developer might come along and say, why is this extra layout if needed call is in here? I'm just going to remove it, and they would never really know that actually that was needed for this case in like iOS 8, and having the test helps guarantee that. Okay, cool. Thank you very much.